Hello, campers. Sorry, my desk is messy and I'm trying to have two conversations at once, but that conversation is no longer important. Good morning. I'm waiting for the stream to catch up, but while I'm doing that, I will say hello. Ooh. Okay, excellent. Everything looks like it is good. I'm gonna unplug this so you don't get an echo. Welcome to BigQuery Camp. BigQuery Machine Learning. I know some of you said you were having some problems with getting your notebooks to start. Try reloading first, see if that helps. And there is also a active investigation that our engineering team is doing. So hopefully we'll get to the bottom of it very, very soon. But it does seem to not be affecting everybody. So if you try restarting a couple times, you might get lucky. Welcome, welcome, welcome. Good morning to everybody. Thank you for joining. All right, so if you have been following along with the SQL Summer Camp, the first 2 weeks were more of an intro to SQL, how it works. We talked about queries and what relational databases are. And today we're actually going to do something I think a little bit more fun. Not that SQL is not fun, but it's very much like utilitarian and a tool. And this is like, as a data scientist, the thing that I'm slightly more interested in is the machine learning part of things. And I have already gone ahead and started creating a project for this. And I talked about how to do this in the GCP video that you guys should have gotten a link to in the email. And if you didn't, the video will be made public soon, but we wanted to make sure it was a little Summer Camp exclusive first. Let's call this project, and it's working for folks. Fantastic. Glad to hear that. Let's call this project Rachel BigQML Tutorial. Yeah, excellent. So my project ID is Rachel BigQML Tutorial. Cannot be changed later. I'm just going to copy that for my own reference. And you can see in this screen, I'm going to zoom out a little bit, I have a couple of different BigQML datasets, BigQuery datasets, some of which have models in them in here. These two aren't actually mine. So this is one from the Python Software Foundation that has information on the PyPI repositories. And then this one is BigQuery Public Data, and this is one I made earlier. And the one I just made isn't showing up because I don't have any datasets or models in it yet. And you will see, it says up here, Sandbox. I do not have billing set up. You do not need to set up billing to do this. You don't need any credit card information. I've disconnected all my credit cards from this account, so I have no way to pay even if I wanted to right now. So no credit cards needed. I got some emails about it. So once you've done that and I have copied and pasted my specific project ID, we're ready to start going. So I started by copying and editing the BigQuery machine learning tutorial, and you guys can follow along if you like. And if you didn't get the link, if you search for BigQuery machine learning, it should be near the top. Streaming does put a little bit of a tax on my internet. There we go. BigQuery machine learning tutorial right up there near the top. So that's how I got there. And then I just hit copy and edit, and here's when I started earlier. And then I made sure that BigQuery was enabled and that I was signed in with the same account that I used to create my project. So some sort of high-level stuff before we get started. What is BigQuery ML? When should you use it? It's not like, gonna be the perfect solution for every project you ever do, probably. So there are some advantages. The biggest one for me is that you don't have to read all your data into local memory. So I get a lot of people asking me, hey, Rachel, my data's too big to read into my hard drive so that I can train my model. What do I do? One option is to subsample, of course, so that you're only learning on part of your data. And another option is to train in a database. So that's what BigQML does. Your model that is being trained, and I think it's TensorFlow under the hood actually, and you're just writing the commands in SQL, is being trained in the database itself. Another advantage is you don't have to use multiple languages. So I'm a big fan of R, I'm a big fan of Python, but not a lot of companies do all of their programming in Python or R. They might use something like C# or Ruby or other languages, Perl. Does anyone use Perl in production? Probably some people still use Perl in production. Fortran maybe if you're working in the airline industry or banking. But most of those languages can interface with SQL. So if everyone in your company is using SQL and you're also using SQL, then it's very easy for you to work back and forth. Whereas if you're off in your little Python corner and everything's being put into production in, I don't know, C# or whatever, it's probably going to take a little bit longer to send that back and forth and refactor it and rewrite it, etc. And another benefit is you can serve, I don't actually need that, your model right after you train it. So because it is being trained in your database, you don't have to like serve your model, train your model, pickle your model, build an API to serve your model, find a place to serve your API from. So it's right in the database and you don't have to do all that sort of ETL and model export, et cetera, et cetera. So basically it's really nice for lightweight prototyping. Particularly if your specific data set is already in BigQuery. All right. One of the biggest limitations of BigQuery machine learning is it's not as flexible as, say, the language of Python. There's a small set of models that are currently implemented, and I believe the plan is to implement more over time. So I've linked to the documentation here, and you can check it out and see if other stuff has been launched. Right now, your options are linear regression. So linear regression is when you are trying to predict some sort of numerical value like price, or I guess you could use it for a number of transactions if number of transactions would be especially high. Also logistic regression, which you can use for classification, and that will do multi-class classification or binary classification, which is what we're going to be doing in this example. And also k-means, which is unsupervised clustering. Well, yeah, it's unsupervised, but you do have to pick the number of means that you think there'll be, which lets you take your, data set and divide it into a certain number of groups based on the given criteria. So you basically have classification, regression, where logistic regression is the classification, and clustering. So it covers most of the things you might want to do with a sort of a simpler problem. And also, we're not going to be talking about this, but it might be relevant to a lot of y'all who are working in TensorFlow. You can upload pre-trained TensorFlow models, and then they'll be served from within BigQuery. So again, if you're working in a shop where you like Python, but not everyone's using Python, or R actually, there is a TensorFlow front end there's an R front end for TensorFlow as well. You can train your model and then send it to your database, and it'll be served from the database. So that's another option. And there is, I've linked here a set of notebooks I wrote a while ago, but regression hasn't changed, about regression. So you can check those out if you're like, I'm not feeling super comfy with logistic regression or linear regression. So that's probably the biggest drawback, is you can't do, all the types of modeling you might want to do, maybe XGBoost, maybe, I don't know, other sorts of tree-based models aren't implemented yet. So we're going to do three things. We're going to create a model. Well, first we're going to learn about our data set. Then we're going to create a model. And then we're going to evaluate our model. And finally, we'll do some prediction. And this is all going to be done in BigQuery ML via Python. Okay, and it looks like some people are, it's working for, some people aren't. If it's still not working for you, try clearing your cache and see if that helps. That might help you out a little bit. And it looks like, just quickly gonna check. Yeah, they're still looking into it. So we are actively working on whatever it is that's giving you little hiccups. All right. So the first thing I need to do is actually link my notebook, my instance, to my project. So this is actually not my project ID. My project ID is this. And you're going to need to change it for the one that you created when you created your project. So if I go over here, I can see that, there we go. Rachel BigQML tutorial is the thing that I called my project. And you will notice that it has dashes in it. So I want the one that is down here and not the one with the spaces in it. The spaces will give you an error. And then we're doing a bunch of stuff, creating our libraries, and we're doing something a little bit different here than we've done previously. So previously, we were interacting directly with the client. So we would create, the client object, and we create a bunch of objects off of it. Today we're actually going to be using the notebook magic. Where's my notebook magic thing? There we go. And I'm going to run all those cells too, just so you guys know when we get to it. It looks a little bit different. So what this does is you put percentage sign, BigQuery at the top of your cell once you've loaded in all of the appropriate magics. And then you can type SQL directly without having to put it in the triple quotes, without having to send it to a query object and then sending the query object through the client and doing all that stuff. This will only work in Jupyter. This is a Jupyter-specific command. The other things that we've talked about can work in any place where you would use Python. So this is a little bit less flexible, but it's also a little bit less typing. So just FYI. And that's what all of this sort of stuff here is doing. Today, we're going to be working for the tutorial with Google Analytics sample dataset, and then for the exercises, you guys are going to be pretending you're a data scientist for a bike share company. And I tried to pick some examples that were really, realistic, like you might actually do in a business setting. Because I'm thinking about some of you working on your portfolios. I want you to have some nice examples of portfolio pieces that are, a little bit profesh. And this particular data set is in the BigQuery public data project. So if we were trying to talk about a data set that we'd uploaded, and I talked about uploading data sets in the GCP video, this would be your project. And then Google Analytics sample is the data set. And then GA sessions star is the table, and it's actually a range of tables. So you'll remember from the Intro to SQL course where we talked about select star. It's a little small. Let me zoom in a little bit. When we talked about select star meant everything. So this means every table that starts with GA underscore sessions underscore, and it could have anything after that. And the way that the data set is actually set up is that each day gets a new table. So we're getting the tables for all days, basically. And then we can look at a couple rows of this table, and it looks a little bit different from some of the stuff that we've done previously. It's a little bit more complex in terms of data structure. So, I'm going to sneeze. Excuse me. It's a little bit more complex in terms of data structure. So we have some fields that look pretty reasonable and normal given what we've already worked with. We have visitor ID, and here we can see these visitors don't have IDs, so they're probably not signed in. We have visit number, so it looks like this is the first visit for these folks, the 8th visit for this person. Each visit gets a unique ID, so if you wanted to count them, you could use that. Angela says thank you. Says bless you, thank you. Start time, and this looks like it's probably in Unix epochs, I think that's what they're called, or Linux epochs, that start counting from like the 70s, like a date in the 70s. And then the date, so this was August 1st, 2017, August 1st, 2017, August 1st, 2017. Those look fairly reasonable. You might have to do a little bit of munging to get this treated as a date. And then we have these guys, and these guys look a little bit different. So what these are, is they're what are called structs or records. So it's basically like a JSON file inside a cell. And if we look at the schema of the table, did I just delete everything? Nope, I just accidentally created a lot of extra cells. Table.schema. You can see that we have visitor ID, integer, string, data string. We're probably going to want to convert that to date time if we wanted to work with the dates at all. And then we have these totals. So this is a record, structs record, same thing. And in it, we have an entire schema that's defined. So we need an integer that we're going to call visits. We need an integer that we're going to call hits. We need an integer called page views. We need an integer time on site. And it looks like all of these are integers. I'm looking for one that's not an integer. And so this one, AdWords click info, is a record. So it's going to have additional nested information under it. You don't need to know all the details of that right now. We're going to talk about it more in the advanced SQL course. But as you're working, you might come across these types of nested data structures. And the way that we're going to get information from within these columns is that we will get the column name dot the field name we're interested in. So in this example, if we wanted to get the transactions field, so transactions here, from the totals column, so we got a little data set from the table. We created a small data set from the table, and then we looked in the totals column, and this is the information from the first row in the totals column. And then you can access into those columns using dot, whatever field it is. So we could do dot new visits, dot screen views, dot session quality dim, etc. So hopefully this can be helpful for you. Yes says, I actually work for a bike sharing company. I'm delighted that I picked a project that was super relevant for you. Or I think actually Matt was the one who picked the data set, but I thought it was a good one. All right, so we know what the data set looks like. Now, to train a model. And I'm actually going to, so we've already loaded in, have we? Maybe we haven't loaded in our magic yet. Yeah, we hadn't. So there was no little number next to the in, so I know I hadn't run that particular cell yet. And I'm actually just going to start it going while we talk about it, because it will take a little bit to train. This is a pretty large data set. I think it has probably hundreds of thousands of items. So while it trains, we'll talk about what's in this query, because this is a big query. This is far and away the biggest query we've written so far in the Intro SQL course, or the SQL Summer Camp is what it's called. Sip of tea. Clearly I need more caffeine. Ooh. So there are a lot of parts here. And I talk about each of them in detail down here a little bit, but I'm just going to have the whole query on the screen because I think it's a little bit easier to follow. So the first thing we want to do is we want to create our model. So it's called BigQuery tutorial.sample model. And I should see that if I look in my console, I'll zoom in a little bit for y'all. If I look in my console, you can see under Rachel BigQML tutorial, which was previously empty, now we have BigQML tutorial, and then underneath of it, we have sample model. So we created this earlier when we were doing just sort of like the boilerplate stuff, and then when we created the sample model, it showed up in this folder. And this is also a place where you could, check it out and run queries. And if you were working with somebody and they were more familiar with like a query editor graphical interface, you could send them this, and then they could work with your model, and you could continue working in Python if that was your preference. Here we're setting the options. So I'm saying that I'm training a logistic regression model. There are some additional options that you can do here. A lot of the BigQML stuff is done for you automatically. So some things that you could choose to add here, you could choose to say which column it is that you want to be your target column. Here I've used this first one and I've called it label. And I think it's the first column you select that gets the training that is used as the objective, because I don't think it has to be called label. So just FYI. Or you could specify what it was up here, but because I need to do a little bit of extra munging, I didn't want to do it, define it up here where this munging bit that we'll talk about in a second hadn't been run. You can also choose, you can choose your optimization strategy. So a lot of this is, again, done automatically if you wanted to use stochastic gradient descent, or I believe if your data set is very small and arithmetically solving the equation would be faster, that's what's used instead. You could also choose your testing training split. Again, it's just sort of done automatically. So a lot of the sort of stuff that you do in preparing to train a model is just sort of handled magically behind the scenes. Then you can see it's still going, because again, we're training a pretty big model here. And then we have the actual variables that we're going to be using that we select. So the first variable that I'm selecting is totals.transactions. For logistic regression specifically, if it tries to predict a null, you'll get an error. So we are converting the nulls to 0. If we go back up here and look at the total transactions we had here, we see that the value for this particular field is none, which would be considered a null, which would give us an error. So we are going to convert all of those nones into zeros, and otherwise it's going to be 1. So we're predicting whether or not there will be a transaction, not the number of transactions. And that's what this if totals.transaction is null, make it 0, otherwise make it 1, and we're going to call that label. And then here we have a if null device.operating systems is nothing as OS, otherwise we don't change it. So what this says is, okay, look in the device column, get the operating systems field. If there's nothing there, or if it's null or none, make it blank, make it empty, and have that be OS. And if there is something there, just keep it there. So that prevents you from saying that someone's operating system is none. We're just sort of like saying it's unknown. And then we have whether the device is mobile. So again, this is from the device column, but instead of the operating systems field, we're looking in the mobile field. We're just calling that is_mobile. GeoNetwork.country. So we're saying where the, transaction, or I guess visit, I think it's called visit, where the visit occurred. And if it's none, we're not going to say people are from country none. We're going to say we don't know. We're going to make it blank. So that's what this if null is doing, and we're calling that country. And then the total page views, and again, if it's null, we're going to make it 0. So we are predicting the total number of transactions given the device operating system, whether the device is a mobile, the country that the visit occurs from, and the number of total page views. Oh, and you can see when you see this, it just means your model is done training. This information down here says what tables, in this case, we're going to use to train our model. So BigQuery public data is the project, Google Analytics sample is the data set, and then GA sessions star are the tables, and then where says which of those tables we're actually going to use. So here we're using table suffix, that's a BigQuery SQL built-in, between, which we talked about in the, I think, the join lesson, and there was a lot of confusion between whether or not between would take the things that it was between, or whether it would be things that are just sort of like one in from that. And we're looking at things that happened after 2016 August 1 and before 2016 June 30th. So, and that's going to be populated out here. So it would be the same as if we were running this on, GA sessions 2016 0801, 2016 0802, 2016 0803, et cetera, et cetera. This is a complex query. This is a fairly large, this is a model that has a fairly large number of things going on in it. Yours don't have to be this complex, but we wanted to show you sort of the range of things that you could do and the options that you had. So you can also say, create model if not exists. There's a lot of other options. You can just say create model. You can create a model or overwrite an existing model, and all of those are in the create model documentation, which is linked in here somewhere. This one is where you could get more information on all the things you can do with create model. So if you see here, there are a large number of possible things that you could change, and we have changed none of them, but you could choose to if you wanted to. All right, we've trained our model. Now, if you are interested, you can get information on the training statistics. So you can see that there were 8 iterations. Each iteration took between 1100 and 2100-ish milliseconds for the training. And you can see that we have loss and also evaluation loss. So we didn't manually do a test train split, but it was done automatically by BigQuery ML. And it also, that test train split was used to do automatic stopping. So I didn't have to say how many rounds to train for. I didn't have to split the data myself. It was automatically split. And at the point where the evaluation loss didn't continue to decrease, even though the loss on the training data did, we stopped training. We called it quits there. You can also see that the learning rate is going up over time, so that's super common. You generally start with a pretty slow learning rate, and then as you get additional momentum, your learning rate will go up and up and up. And again, we didn't have to set that. I didn't have to futz with it. It just sort of happened. So like I said, great for very simple, lightweight model training. You just want to try something out and see if it works. Okay, so we didn't have to do a lot, but how'd the model do? How are those defaults doing? So in order to evaluate the model, we are going to use this ml.evaluate model function. And you can see that we're using select star, not something you generally want to do, but this is the model evaluation is not that big, so we should be fine. It should not be a problem. And then the model is BigQuery tutorial. BigQuery tutorial. It's one of these. Sample model. And then you actually just repeat the information that you gave the model originally. So if we run that, it's take just a second. You can see a number of different, what are they called? Metrics. Wow. Okay, another step 15, more caffeine. You can see a number of different metrics. Precision, recall, these are precision, recall, ROC, AUC, receiver, operator, characteristic, area under curve are generally more used for binary classification, which this is, accuracy, F1 score, log loss, so numbers you can look at, especially for binary regression models, or binary classification models. I tend to prefer looking at the AUC, the area under curve, and we can do that. So we're going to run a query that gets the information that we need to plot the area under the curve or the receiver operating characteristic. And instead of just, here, I'll show you. So if I just run it here, it all gets spit out into the cell output, which is not super helpful. If I add something here like ROC, it will assign this to the variable ROC that I can then work with as I would any other Python data frame. So basically this is loading it into my local Python session as a variable called ROC. And we can look at just the head. Yep, that looks right. And now we can use this information to plot the receiver operator characteristic. Nobody says it all that way. And the area under the curve is the false positive rate by the true positive rate, aka recall. So if we take a look at that, and if you're not super familiar and you don't do a lot of binary classification, the closer it is to sort of this perpendicular, the less separation between classes you are getting, and the closer it is to sort of a very tight curve that hugs the upper hand and the left side, I guess, of the graph, the better separation you get between classes. So this looks pretty good. I'm pretty happy with this. And also if we look here at the model, we get a 98.5% accuracy, pretty good. Don't only use accuracy when you're doing binary classification. Okay precision, okay recall, pretty good ROC accuracy, so not bad overall, I would say. Especially for a model that I did no futzing with. It just happened automatically. Okay, so it's pretty good. Can we use it to predict? Yes. Do we need to save our model somewhere and then upload it somewhere and then pass the data to it? No, it's already in our database. We can just ask for predictions. So we're going to do a little bit of a fancier prediction here. So we are going to actually predict given the whole model, right? So this is the code that we used to create the model originally, basically. You probably could alias that, but probably not within two separate queries, or if you would, it would be weird. I just repeat the code, and I think it's easier looking at to figure out what goes into the prediction, so I think this makes sense to me. I am, from the prediction, because I'm going to predict everything, I'm going to select country and then the predicted labels as total predicted purchases. So I'm summing over the predicted labels. I'm grouping by country, and then I'm going to order by the total predicted purchases descending. So what this says, I'm selecting the country column. I'm going to I'm going to look at all purchases from the same country together. I'm going to sum the predicted labels from the total predicted purchases. So this is my the number of transactions the number of visits which I anticipate will become a transaction. And then I'm going to have that number by country. I'm going to order it so the top country is first, and then I'm only going to show the first 10 rows. And that should, if you took the Intro SQL course and did the first 2 weeks of camp, that should be more or less helpful, more or less review. And you can see our number one country that we predict to have transactions from is the United States, followed by Taiwan, Canada, India, Japan, Turkey, Germany, and then we sort of get into ones where we think we're going to have one, and it looks like at that point the list is just alphabetized. So we're not like, Germany isn't like 1.4, it's, and we're just cutting off the end, it's just first in alphabetical order. We can also, we can treat the prediction output like any other type of SQL data. So instead of going over countries, we could also do by full visitor ID. So these are people that we think are more likely to make, I'm assuming that visitor ID is linked to an account, like an individual, that we think are more likely to make purchases. So this person, we would predict they'll make 4 purchases, and these folks, we predict they'll all make 2 purchases each. So if we were running B2B or doing something business to business, this might be the business that I'd want to, reach out to and be like, hey, I'm going to help you. Is there anything, any questions you have? Because we think they're pretty likely to make a purchase in the future. And then if I didn't want to keep working with this model, I could go into my dashboard here and select my model. So this is the whole data set, including my model. This is just my model, and I could delete them here. You can also delete them through the client, but I like to see them before I delete them. I don't know. Maybe that's a little bit sentimental. So that's the whole thing. We looked at the data, we trained a model, we evaluated our model, and we made some predictions, and then we used those predictions to, in our fantasy case, decide what to do as a business, I guess. I am going to take questions now. And I'll start with the YouTube chat, and then I will head to the Learn forums. The next step for y'all, feel free to stick around for questions, is to head over to the tutorial notebook, which I think I already had open in another tab. Yeah, I definitely had open in another tab. And again, we've tried to have like a pretty realistic problem for you. You can see that I have an error here because this is not what my project ID is. So you need to replace this with your own project ID. And then we have some more sort of thoughtful questions for you to sit and think about, and then also some queries that we'd like you to write. You can see that there's nothing in this query, so it's not going to run well. Yeah, and if you have any questions, please head over to the Learn forums, kaggle.com/learn forum, and I'll be checking in here throughout today, and yeah. All right. Heading to YouTube chat, which I have been doing my best to ignore because otherwise I get real distracted and just answer questions the whole time. Jake C, what is she trying to achieve with query? So, depending on the query, you might be learning about the model, you might be learning about the data set, you might be training the model, or you might be making predictions using the model. So, sort of general idea. Jake C says, what's AGI? Something. What does the A in AI stand for? Automated? Automatic? Artificial general intelligence. A little bit more caffeine. It's like the singularity, basically. I'll be honest, I'm skeptical. Abby says, I missed it all. No! The recording will be immediately available, so you can go back and watch the recording. And Abhishek helped out. Yeah, artificial general intelligence. Thank you. This was easy to listen to someone talking about it than to read about it. I also agree. Especially for, you see a big query and you're like, oh, there's so many things in it. What does it mean? And I definitely, when I started coding, I would like copy and paste code and I wouldn't understand what it was doing. I was just like, this is the bit that works. And I'm just going to keep repeating this bit that works. And the more I learned, the more I was like, oh, all of this has meaning. Some of these are names that I've assigned previously. Some of these are like commands that I can't change the name of. And it started to make more sense. So, Sai says, how can I send a request to this model from, let's say, a website? Excellent question. So if we check out the, where is it? So it will depend on the language that your website is written in. It has an API. And the BigQuery API supports a lot of languages that I do not remember all of the here we go. C#, Go, Java, Node.js, PHP, Python, and Ruby. So depending on what your specific website is written in, you would give your specific account that you're using to run it the correct permissions, and then you could use the API to query the model that you trained. Yeah. Maya says, can you please give a link to the list of TensorFlow models, the TensorFlow models that it supports? If you mean the create your model, I believe it's under the create model documentation. So linear, logistic, k-means, and then TensorFlow. And then the create model statement for TensorFlow model methods is a little bit more complex. But you should be able to serve, I believe, any TensorFlow model. Don't quote me on that, because I haven't tried it. But if you do, let me know. I'd be really interested to see. All right. Ronnie says, is this exercise the one we need to complete for the certificate? Yeah. And as long as you create a model, you should be fine. But we've added some additional wrinkles to give you the real data science experience. So yeah, hopefully you have fun and enjoy it and don't find it too frustrating. But it should be very, true to life, shall we say. All right, let's see else. Monica says, did anyone else get an unexpected identifier error when they copied and pasted the first bit of the query into BigQuery? Oh, that is probably because, I don't know particularly why that error happens, but I have a couple of ideas why it might be. So one might be that you see here where I actually create a data set called BigQML tutorial. By the way, the reason why you need to link a BigQuery account to do this is because the Kaggle BigQuery account does not have write permissions. And because you're actually writing your model to the database, I think I mentioned this somewhere in the notebook, because you're actually writing the model to the database, you need to be able to write it. So if you didn't create the data set, or you created the data set with a different name and then try to refer to it by the same name, you might run into trouble. So the data set that we create here is this one, BigQML tutorial. So I could have given it any name. And then every time we refer to, every time we refer to the model, we need to say the project name, BigQML tutorial, the dataset name, BigQML tutorial, and then the model. We don't have to say the project because we have already linked our client to, in my case, Rachel BigQML tutorial. If you try to use the same project name, I believe you'll get an error because it's already been used, or it'll automatically add some numbers at the end. Yeah. John says, not running anything directly in BigQuery, just executing through the notebook. So you are running things on BigQuery. You're using the BigQuery API through a notebook. You could do all of the same stuff directly in BigQuery using the query editor. I mean, you're welcome to do that. I prefer to work in, Python. Personally, if you really, really like using the graphical interface, go ahead. I'm gonna stop you. Have fun. Yeah. Let's see. Other questions. It's pointing out, not total number of transactions, but transaction or no transaction. So we are, for the tutorial, we did binary logistic regression linear model. We did a binary linear model? Yeah, we did binary logistic regression. I was like, there's no such thing as a binary linear model. What's that? For the tutorial, I believe you're going to be using a linear model to predict the number of total transactions at a given bike station. So, all right, let's head to the forums, and I'll keep an eye on the chat. Scroll. Oh, Tanush says, can we do NLP using BigQuery? Also, you mentioned the train test split is automatic. What is the percentage of the split? What is the percentage of the split? That's a great question. I believe it's in here. Let's see. It should be, let's see. Learning rate strategy, learning rate early stopping, data split method, check it out. Auto split. The automatic split strategy is as follows. When there are fewer than 500 rows in the input data, all rows are used as training data. When there are between 500 and 50,000 rows, 20% of the data is using as evaluation data. When there are more than 50,000 rows, only 10,000 of them are used as evaluation data in a random split. Great question. Thank you. Can you do NLP? It depends. So you can definitely store text data in BigQML. Generally, I think it's more common to store documents, in particular, in NoSQL, and I don't remember what the NoSQL one is called. Blob store. I don't even know if that's a Google thing. The way that people tend to work with text documents in something like BigQuery, and I've definitely shoved some text documents into a relational database, is that you'll have one row per document, and then you'll just have like the complete document text. And I mean, text isn't that big, so each row might be a little bit chunky, but it's not that big. And BigQuery is designed to handle like big petabyte data sets, so you should be fine. But yeah, if you had a more like complex forum post structure where people can reply to people and there's trees, I might not use BigQuery for that. Yeah. Rakavendra says, how to choose between AutoML tables and BigQuery ML? Oh, great question. AutoML tables is, I mean, it assumes more background knowledge, basically. So BigQuery ML is, it's just a little bit faster and lighter weight in terms of view. In auto tables, you have a little bit more control. You can do a lot of more different types of models. So if you were, for example, working on a Kaggle competition, I might go with AutoML tables over BigQML, just because you have more control and you can try more different things. Although one thing that is pretty easy with BigQML is stratified modeling. So if I wanted to, say, build a separate model for every country, I could do that, and I could save each of my models as a separate model and then pick which one to apply at a given point and then apply that one. I don't know how easy that is to do in AutoML. I've played around with it a little bit, but I haven't gotten super, super deep into it. So for that, I would probably use BigQML. And, I think it's fine. It works okay. I don't love model tuning, so it's great that a lot of it gets taken care of automatically. Christopher says, is it possible to apply BigQML in deep learning? Not yet. I don't think... The only methods that BigQML has are linear regression, logistic regression, k-means, and TensorFlow models. So I guess if you had a deep learning TensorFlow model that you'd already trained, you could use BigQML to serve it, but you can't train deep learning models. It's something that might come out in the future. And Abhi says, yes, you can use Blob for storing documents. In the tutorial, it says, ensure you've selected a BigQuery account in the kernel settings sidebar. How can I handle it? So in your in your tutorial thing here, you would click here and it'll pop up a pop-up, and you have two options, and one is the Kaggle public account or whatever it is, and the one above it is link a BigQuery account, and you need to have a GCP account, and you click on that and it takes you through a little OAuth workflow, and then you can use your personal BigQuery account on Kaggle. Yeah. Felice says MongoDB. Yeah, I think that's I think that's one of them. You can tell I haven't worked with NoSQL all that much. Like, I know about it, and I've written a couple of queries, but not a whole bunch. Also, there's a lot of work. I haven't worked with them, but they seem very interesting on graph databases. So the database structure is, instead of like tables, like a graph, like, you know, nodes and edges and whatnot. And that seems interesting as well. But I don't know. I've never gotten super deep into database. I just need to know how to use them in order to do my job. So that's my level of knowledge. Tanush says, can we provide train test percentage split manually? Yes. That is custom. So you can set a custom column, and then, you know, so whether or not it's in the train test split as a Boolean. And you can also use sequential splitting. So if I had, like, I don't know, that would be a weird thing. But if for some reason you wanted to train your model on customers under 50 and then evaluate it on customers over 50, you could do that for some reason. I don't know. That seems like a weird thing. Or if you wanted to train a model on some range of dates and then test it on a different range of dates, you could also do that. That might be relevant to some of you. How can I do hyperparameter tuning in BigQuery? Does it use grid search or Bayesian model? None of the models that are currently implemented would make sense for that. They're just sort of done using, I mean, K-means is its own thing, so we'll look up K-means. But for the regression, they're fitted either using gradient descent or, I believe, you know, normalized equation. I don't know if they do add deep learning. I don't know how they would do that, or something with a bigger parameter space. Oh, I said I was going to go to the forums, and I got completely distracted by the YouTube questions. It happens every time. All right, Alan had a question. Any possibilities that BigQuery will add to the top of ML models usable? It sounds, from talking to people who are familiar with the project, like that is something that they're interested in doing. Any possibilities you will see big improvements on dashboards, etc., for data visualization? Oh, I don't know that. I know that Rachel really likes libraries attached to R. I like Python and R. I like R for what R is good for, which is to say, working with tabular data. So, yes, it sounds likely. I have no idea. And yes, I do like R. All right. Other questions? Let's see. The model is not learning. I'm gonna save this for. Oh, actually, this is different. After creating a model on the Austin bike share data, I ran the ML training info, but the result showed only one row with a large error and learning rate as none. So this might be because there is a null value in the column that you're trying to predict. So I might try getting rid of nulls and see if that helps. If it doesn't, I don't know what the problem is. I'll look into it. I'll be around today. BigQuery ML. What are the potential limitations of BQML and data analytics tasks? I mean, the big one is that they've only implemented 4 methods so far, which is, limiting. You know, you can't use it for everything. The other thing is your data does have to be in BigQuery. I guess that's a limitation I didn't say. If your data doesn't work in BigQuery, it's not going to work for you. You are not going to have a good time. So that would be the 2 big limitations for me. Our feature, I'm training a model on the exercise. The exercise is to use the time stamp to extract the hour from the training data. The values of the resulting column contain the date, including year, so every value in this column is unique. Doesn't make the future useless? Shouldn't we create separate features for the hour of the day and the day of the week instead? Thanks in advance. No, because those have a relationship to each other, right? So if I had, I mean, it's basically a time series problem, right? So if you have a strong belief that all Mondays will be like other Mondays, then that's completely reasonable to add as a feature. But probably you're also going to expect to see some sort of change over time in a predictable way if there is a temporal component to the problem. So it wouldn't be wrong to have it wouldn't be wrong to have the hour of the day and the day of the week, especially if you think that you're going to see patterns in a weekly and daily way, but that's not going to be able to capture change over time. So good question. It's not wrong, but you probably do also want a date feature. I think that is from a different thing. Blackjack problem, intro to ML, summer camp SQL. I got an email. Oh yeah, I responded to this. I'm not able to find a way to create a new discussion. I'm doing from the beginning, but I got the email. I'll just reply to this person. This doesn't look like it's generally relevant. All right, back to YouTube. Jerry says, can we integrate Jupyter notebooks from our console directly to the BigQuery sandbox? You can. I believe we've done a little bit of infrastructure work on our end. So we do a little bit of stuff to handle credentials in a little bit more, easy way. But yes, you could absolutely use Jupyter locally to integrate with BigQuery ML. You just have to handle your credentials. The other thing that you can do is, I don't know if you're familiar with Platform AI notebooks. So it's another Google product. So it integrates with BigQuery really easily. And it's just a hosted Jupyter Lab notebook. Platform AI notebooks, Google. There we go. AI platform notebooks. So these are Jupyter Lab and not Jupyter. And if you really need vanilla Jupyter for some reason, these won't work for you. But this is another way if you wanted to use a hosted notebook and didn't want to use Kaggle. For example, if you were working with very sensitive data, I don't think we're HIPAA compliant. Please do not give medical data to us right now. We'll let you know if that's okay at some point in the future. This would be another good option, and they support Python and R, the two languages that you would want to know. Jesse says, if I were in a ML competition, would it be a good approach to first use BigQML, then AutoML Python, or would it be better to go directly with Python from the beginning? It depends. I mean, one thing that is super duper common in Kaggle competitions is that people will train many different models and then ensemble them together. So there's nothing to stop you from having like a BigQML model, an AutoML model, and like 5 other things that you've trained and then squishing them together using blending or stacking or other techniques and using that to get maybe a better result. Who knows? Varun says, can I complete previous assignments to get certificate? Yes, as long as they're done by the end of the advanced SQL course, which is the next thing that's coming up. And then the deadline is the Friday of the week of the advanced SQL course. Sanai says it's Data Lab. I believe it's different from Data Lab. Pretty sure. Yeah, pretty sure. There are questions. What companies hire for this kind of skill set? I think the last job posting I saw specifically looking for someone with a lot of SQL knowledge was Twitch, and they were looking for an advanced data analyst. And it was like, you need to know SQL. Python and R would be nice, but you do need to know SQL. And it's, I mean, certainly every place that I've worked. I've had one job after grad school and it was Kaggle. But, every place that I've worked and all my friends who are in data science at different companies, pretty much all of them have to use databases and get data from databases. A lot of researchers put their data in databases. So knowing SQL is a broadly applicable skill. If you are interested in working primarily with SQL, most data scientist positions are going to want you to also know Python or R or sort of other machine learning libraries. Data engineering positions are more likely to be pure SQL or more predominantly SQL because you're in charge of like setting up pipelines and handling data and doing data validation and making sure that like things go correctly and update correctly. So in my experience, data engineering roles tend to have a little bit more SQL in them. And then something like a database administrator would be pretty much all SQL all the time, and making sure that the databases do good. And I mean, pretty much every company that is large enough has a database administrator or someone in charge of their database. So many companies. That's the answer to that question. Ritwick says, do I need to import magics if I use my local Jupyter environment rather than using Kaggle kernels? You need to import the BigQuery specific magic, but the built-in Jupyter magics. Kaggle kernels are Jupyter, right? So I can... if I downloaded my notebook, you'll see that it's an IPyNB, and I could upload any IPyNB to Kaggle directly. So all of the built-in Jupyter magics will work. Timeout. The best use of this optimization library. So all the Jupyter magics will work out of the box. The BQML ones you need to import yourself. Abhinav says, how to commit the exercise? Can I just see the copy and edit? You can just edit. To commit, you would hit this version, and it will run a different version. It will run the current state of the kernel in a new session, so top to bottom. Andrea says, where's the bike rental data available so that we can upload it to GCP? Great question. You don't actually need to upload it. You can use any BigQuery dataset to train your model. So you can see here, our model is in BQML tutorial sample model, but the data that we're using is actually from a completely different project. It's from BigQuery Public Data Project rather than the project that I created, which is Rachel-BQML-tutorial. So as long as you have read access to the data that you want to use, you can use any data set. So the bike share data is already on BigQuery. You don't need to put it there. If you wanted to upload your own data, then we talked about that in the GCP video. Nan says, can you talk some about budgeting BQML if you're going to integrate it into your ML pipeline completely? I tried a few weeks ago. It was pretty unsuccessful. Budgeting in terms of like time or money? No, I guess is the answer to could I talk about it? Post on the forums, and if I don't know, I'll nudge somebody who does know until they show up and answer your question. Happy to bother people on y'all's behalf. And says, can you address at which point BQML will start billing me if I want to load a large Kaggle competition data set into the Google Cloud platform? So it will not bill you until you set up billing. I think it'll stop working and be like, you've used your free quota. If you want to keep using BQML, you should, set up billing. And I believe you have 1 terabyte of read, write, scan access per month on a rolling basis. I think it's a rolling 28-day basis. So that's scanning. I don't know about storage specifically. I checked the docs. Yeah, good question though. But it won't be surprise billing until you allow it to be billed. And to do that, you would enable billing for your specific project that the data set is attached to. Let's see. 8 people says, I'm getting an error, bad request, 400 syntax error, unexpected string literal. Oh, the thing there is that you are probably using single quotes. So I'm going to show you my, well, it's upside down, but you are probably using single quotes. This one, you should be using backticks. This one. It's on the same key as tilde, that one, in my, on my keyboard, not my laptop, my keyboard. Zohair says, how to run prediction on fresh data? Really good question. Let's go down to the prediction. Creating the model, evaluating the model, predicting. So Yeah. I think you would want to change. Yeah, so I'm guessing you'd want to change the where you are getting the data from, and then also, in this case, the where. So this is filtering what part of the data set, so in this case, it's filtering which tables you look at, and if I changed which tables I looked at here, I believe it would change the, I believe it would change the data that we looked at. I think. Well, let's try it out. All right, where were we? We were down here. We were predicting things with our notebook. And let's really quickly... Did we set up our client so that I can list my data sets really easy? Client, data set. All right, now I have to remember how to do this from a couple of weeks ago. Okay, so it was dot. I want to list the tables. All right, list tables, and I think I need to give it the data set. Let's see if this works. And then I think I need to cast it as a list. Nope. I think I can cast it as a list by putting it at the beginning. I vaguely remember all of this. Yeah, yes, excellent. Okay, so here we have all of our beans. This is just printing all of the items in my list. I want to see what they actually are. For in. Will that work? Nope, that's still telling me what they are. Okay, and 8 people, it sounds like the ticks solved your problem. Okay. What if we actually say that we want to run it from 2017-09-01 to 2017-10-01? All right, do we actually have any data in that range? 7 to 8. Let's try going in front of it instead. So 6 to 7. Yeah, okay. So you just change the data that you are selecting from. Great question. Yeah, that made sense to me. Thank you, Suhair. All right, so it's been a little bit over an hour, and I don't want to keep y'all all day. I want to make sure you have time to play with the exercise, which I hope will be fun and interesting. If you run into any problems, please check in on the forums, the Learn forum, so kaggle.com/learn-forum, and we'll see each other on Kaggle. Thanks for joining. If you are not signed up for the emails, you can sign up for them. The next camp is going to be, let me look at the date because I don't have it on the top of my head, but we're going to be doing advanced SQL. So we're going to be doing stuff that's a little bit fancier, August 27th through 29th. So you've got about a month, and then we're going to fancy with it. We're going to talk about nested data structures. We're going to talk about windowing, I believe. So it should be a lot of fun. I'll see you guys then. And if you're interested, I do live streaming on Fridays at 9 a.m. Pacific time, so same time slot as this. And on Wednesday, we usually read papers. And we haven't picked the next paper yet, so I'll be putting a vote up for that soon on YouTube. All right. Thank you for joining, everybody. Happy querying, I guess, and I will see you on Kaggle. Bye.